The discovery of the electron. In the mid-1800s, scientists wanted to know whether the atom was really indivisible. They also wanted to know why atoms of different elements had different properties. A major breakthrough came with the invention of the Crookes tube, or cathode-ray tube. What is a cathode-ray tube, and how does it work? Everybody knows that some substances conduct electric current. That is, they are conductors, while other substances do not. But with enough electrical power, a current can be driven through any substance, solid, liquid, or gas. In the cathode ray tube, a high-voltage electric current is driven through a vacuum. The tube contains two pieces of metal, called electrodes. Each electrode is attached by a wire to the source of an electric current. The source has two terminals, positive and negative. The electrode attached to the positive electric terminal is called the anode. The electrode attached to the negative terminal is called the cathode. Crookes showed that when the current was turned on, a beam moved from the cathode to the anode. In other words, the beam moved from the negative to the positive terminal. Therefore, the beam had to be negative in nature. The German physicists in Crookes' time favored the wave theory of cathode rays because the beam traveled in straight lines, like water waves. But the English physicists favored the particle theory. They said that the beam was composed of tiny particles which moved very quickly, so quickly that they were hardly influenced by gravity. That was why the particles moved in a straight path. Notice how an experimental observation led to two different theories. Crookes proposed a method to solve the dilemma. If the beam was composed of negative particles, a magnet would deflect them. But if the beam was a wave, a magnet would cause almost no change in direction. Particles would also be more easily deflected by an electric field. In 1897, the English physicist J. Thomson used both these techniques, magnetic and electric, to show that the rays were composed of particles. Today, we call these particles electrons. The term electron was suggested by the Irish physicist George Stoney in 1891 to represent the fundamental unit of electricity. In 1911, a young American physicist named Robert Millikan determined the mass of the electron: 9.11 times 10 to the minus 28 grams. To get an idea of how small this is, notice that minus sign up there in the exponent, and think of all the zeros we would have to put before the 9 if we wrote the entire number as a decimal. Next, someone had to prove that the electrons weren't coming from the electricity, but were being given off by the metal electrodes. Proof that metals do give off electrons came from the laboratories of Philipp Lenard, a German physicist. In 1902, he showed that ultraviolet light directed onto a metal makes it send out or emit electrons. This effect, known as the photoelectric effect, indicated that atoms contain electrons,